I will try my best to explain how to create a hardware design that accelerates some function using a simple design for a simple adder. And we're going to accelerate these functions using the PYNQ board, which is a Xilinx boards. And to be aware, Xilinx boards uses the AXI protocol a lot to transfer data from the processing system to the programmable logic back and forth. Okay, so in order to create a hardware block that takes in information continuously and manipulates this information and sends it back to our software, um, we actually have a something called a DMA controller, direct memory access controller. So this controller uh, is initially um, set up by the processor. Okay, all of its registers and settings are set up using the processor, but once that's done, okay, it can automatically take data from memory, send it to our um, block design. Okay, and once our design is ready and wants to send the data back to the processing system, it takes the data and um, writes it onto the memory. And all these three entities, okay, our design, the DMA, and the processing system will communicate through XI protocol signals. Uh, some of it will use the memory mapped XI, okay, and our design will use the stream XI, and to set up the DMA we're going to use the XI Lite. The difference between these three protocols is in what control signals it does have, okay, to what complexity it can handle, and uh, what size of data could it handle. Okay, so um, as we can see here, our processing system is gonna have actually two XI ports, one master port and one slave port. The master port, which is a general purpose port, okay, is going to be used to control or to set up the DMA registers using the AXI Lite protocol. Okay, so uh, it is master because our processing system is the one that writes or controls the slave, the DMA slave, and this S here denotes slave. It's following the DMA naming. Okay, and for the other port, which is the high performance port, we see that it's a slave XI port because actually this port connects the DMA directly to the memory. Okay, it looks like we are connecting to the processing system, but we're actually getting connected to the memory. Okay, it's creating a direct connection with the memory. Okay, so we see that our DMA, which has both this master XI stream to memory mapped interface and master XI memory map to stream interface connected to our memory, and these two interfaces will be used to read from the memory and write onto the memory. Okay, once the DMA has to send or receive data from our XI stream device. Okay, And the reason our device uses XI stream is due to the fact that it is a simple interface when it comes to controlling it, and it allows large bursts of data transfers, okay, which is crucial. So we will see that our DMA has uh, two interfaces to connect with our design. One interface is called the master XI stream. I have highlighted it in red. Okay, memory map to stream, which will send our memory mapped data inside the memory to our streaming device using the stream XI stream protocol. And once our XI stream device has finished processing the data and wants to send it back to our processing system, it's gonna send it onto the slave XI stream to memory mapped interface port on the DMA. Okay, and the DMA will take care of sending that back into the memory and then into our software code. We're gonna see all of this once I start the design process.